Okay, this is Mrs. Crary. I have two labs in your assignment. One you can play with, mess up, doesn't matter, doesn't hurt your grade. It's just there for you to learn. The one is actually, the other one, lab 1 with the ping pong ball, is something that you need to work on for a grade. Okay, the first lab, the one that you can mess up with, is an introduction to measurements with Pivot Interactive. So you don't even have to play with this if you don't want to, but it's an opportunity for you to not feel worried about it impacting your grade. Now, I have done this on the iPad. It won't let me share my screen with you when I'm on the iPad. So I'm doing it on my Mac Pro, but I have actually completed the lab on the iPad just to see what it's like, to see what the student's interface is. So I can attest to the fact that there's a couple little things you gotta be careful with your fingers, but other than that, I'm actually pretty impressed. So we have this video. Read the instructions word for word. Take your time. Labs are worth 20% of your grade. Okay, so here we go. I got a video. It shows that I have this mortar that's firing. It tells me click the tool icon in the upper right corner of the video. This menu holds all of the tools that you need. Okay, so they tell me I need to click the tools. They tell me I need the ruler. They tell me I need the stopwatch. Okay, this stopwatch, by the way, can be reset at any point in time. This ruler can be moved. This ruler can be slanted. Okay, so depending on, I want it parallel with the mortar rocket thing, whatever it is. Okay, and then say, all right, now click the tools. We did that. We need to advance this. I can pull this back until I just want the firecracker right outside of the out of the cannon, and I don't like this ruler being so slanted. And notice I have actually aligned this ruler so that the 0 mark is right at the right edge of the mortar. Okay, now once you get that ruler aligned for this lab, and probably a lot of others, especially when you're taking distance versus or displacement versus time data, if you move that ruler, you've got to go back. So be careful. That's something that I had to have done, or that I found that I messed up because I got my thumb on that ruler and I moved it. Now click on that. Okay, now press the 0 button. So there it is, located at 0 centimeters, and I want it to be at 0 seconds. And then I'm going to go, I actually found that it was easier if I wrote down all the times that they wanted, which, by the way, they messed up the last one. Number 7 should be a 0 there, and I can fix that for you. I wrote down all the times, and then I said, okay, I got to go find all the distances where the mortar is at those times. And I did that quickly by having a piece of paper so I could focus on this, just the graph. So I said, okay, there's the first one. So I looked at it and said, that looks like 1, 2, 3, 4, 5. I called it 5.5 centimeters. Okay, and I wrote that down. The next one was 0.042. So I kept hitting this button until I got to 0.042. And I found that, okay, it's, I don't know, 23.9. And then I went to the next one, which was 0.073. And I found its location to be, I don't know, 59.1. And so I went through all of the seconds, and I measured its displacement, how far away from the origin, and I typed in all my values. So I'm going to type them in. And this is in centimeters, by the way. Which we want to be in meters, but that's okay. 59.1, 75.7, 94.9. Oh, did I mess up? I did. This is 112.5. 94.9. I must have skipped one somewhere. What's this one? 75.7. Oh, okay, sorry. It's hard to do this quickly, so take your time, as you can tell. Okay, 59.1. So I must have missed one somewhere. There's the one I missed. Okay, got it. All right, now I've completed that task. Fill in the distances. Next. Great, now let's calculate the velocity. It's tedious, they said, so we want to use some of the tools that they gave us. So they tell me to go up here and to this 3 dots, and I want to insert a column to the right. I'm going to change this column name to velocity. And now I'm going to input a formula. So how do I calculate velocity? Well, they weren't very clear, right? We could have calculated the average velocity in between each spot. We're going to use the distance. We're going to change the formula, and we're going to use distance divided by the time. And there we go. All right, so here's a whole bunch of calculations. And what units is that? That is in centimeters per second, because that's what we've got going on there. Now, we could actually convert that, could we not? Let's change the formula so that we convert that. So right now I'm taking centimeters divided by seconds. 100 centimeters equals a meter. So if I divide by 100, let's see if I can get rid of some of these things. Let's cancel. Let me edit, change the formula. I want distance. Now here's something I actually haven't done, and that is to change the formula. Let's see. Change the formula. I want to divide by 100. There we go. It let me submit. All right. Now I've converted to meters. Okay. And look at all these decimals. I don't like that. So let's change the settings. Let's change the format to decimal places. Let's say I want 1. Okay. All right. So there we go. There is my velocity in meters per second. My variable might be V. This is my displacement. This is my time. Okay. Maybe time. Yeah, isn't T. Yep. Got it. All right. So did I answer the question? I did. What's the velocity? Oh, it is approximately, I don't know what it was. Approximate 55 meters per second. Okay. More like 56, sorry. Okay, and that is that. All right, now we can use the table. Let's see how we can use the graph. So I want to add something to the vertical axis. And what do I want on the vertical axis? I want distance. Done. And that had already been set for time on the horizontal, but we could have changed that. Okay, so there's my data point. Look how nice and straight that is. That's a position versus time curve, right? Then they tell me to show origin. Right now it doesn't show anything. It just has, it's just kind of out there. I don't know where the axes are. So let's see if we can include the origin. Now I can see actually 0, 0 on the graph. Okay, the next thing they tell me is click the linear regression. So this looks pretty linear. So if I have a whole bunch of curve fits that are available to me, linear line would follow this y equals mx plus b, and I have added this linear curve fit, and man, does that look nice. Okay, so, and here's all the equations, or actually all the terms. So I know that a is equal to 56.95 centimeters per second. Notice what we actually, yeah, this is in units of centimeters because I didn't convert my distance. Distance was still in centimeters, right? Okay. So A, which is the slope, B, which is the intercept, and here it is right here. Okay, so they're going to ask some questions about that. I think that is it. So that's kind of like an opportunity for you to play around without worrying about it. So try that if you want, and then if you then you need to start working on the other one, and that one actually is going to be graded. So I will obviously be very gracious on this first lab. So good luck. Message me if you guys have any questions.